And welcome to this lesson where we'll be talking about logs as inverse functions. So essential question, how do exponential and logarithmic equations relate? Well, spoiler alert, they're inverse functions. Just the same way as the square root of x and x squared are inverse functions. Or x cubed in the square root, in the cube root of x are inverse functions. So are logarithmic and exponential functions. If you take log base a of a to the y, you're just going to get y. Log base a of a to any power, the log base a and the a, they are opposite operations. They're inverse operations, and therefore you just get 1 and you just get whatever your exponent was. And I know I'm jumping ahead of myself because I'm excited, but we'll get more into that. So by the end of the lesson, you should be able to introduce logarithmic equations as inverses, and then convert between logs and exponents. If we first think about the inverses graphically, let's look at the graph of 2 to the x like we've looked at before for exponents. And if we zoom out, it would look something like this happening for an exponential equation where it just gets bigger and bigger and bigger and bigger and bigger. Well, a log is the inverse, so it's actually going to start really big and then taper off to a certain level. And if you can see, you have y equals x on your reflection line here. You can see the symmetry between the two inverse functions when they are graphed over y equals x. So what does that look algebraically? Well, this is what it looks like right here. The writing y equals log base a of x is the same exact thing as saying x equals a to the y. Now, that's kind of confusing because you have y equals and then x equals. Well, let's experiment here. So if I have y equals, so if I have inverse functions, they should cancel each other out. I hate using the word cancel each other out, but log base a of a should give us 1. Correct? Okay. So y equals log base a of x. Well, x equals a to the y, right? So I'm going to put a to the y in there. A to the y. Look at that, log base a of a, they're inverse functions, and you just end up with y equals the exponent y. Here's another chart or another graphic organizer that might help you out if you want to copy this down. Exponential form, y equals b to the x, and then you're going to switch the locked, quote unquote, locked positions in the logarithmic form. So notice how y is free here, and then in the logarithmic form it's locked up, so it's part of log base b, and then x is kind of locked up over here because it's the exponent, it's not by itself, and then it becomes free. So they kind of switch positions there. Here's an example of a problem you might see and why we need logs to solve for x. So log base 2 to the x equals 30. There's no way to write 30 as a power as an exponent with base 2. So let's use log base 2 of 2 to the x. So because we're using log base 2 and 2, log base 2 of 2 is going to equal 1, and therefore I have x here. So remember, just because this is raised to a power, this can come down here, And so you have x times log base 2 of 2, that's 1. So I'm left with just x. And of course I have to do that to the other side, but now my x is separated by itself, and I have log base 2 of 30. And you can do one of two things. You can leave that as a simplified answer. I wouldn't expect you to know exactly what log base 2 of 30 is. Or you can calculate that with a calculator and do x equals the answer. Either way. So that's the relationship between exponential and logarithmic equations. Make sure you go ahead and start your homework assignment. If you have any questions, reach out to me. Love to help. Hopefully I'll see you in live class where we can talk about this some more, where you can get some extra help. If you can't make it there, watch the live class recordings. Definitely, if you're struggling, come to Math Cafe. I'll be there Monday, Tuesday, and Wednesday at 11 a.m. Where we can just talk one-on-one, and I can help you out. If that doesn't work for you, there are teachers in there 9 to 3 every day that are willing to help you out. So important thing to remember, make sure you copy this down, and I will see you later.